Hi students, welcome to physics class. Today we will discuss about the intensity of electric field at a point on the axial line of electric dipole. Before that, let us understand the basic concepts. First one is source charge. Source charge is one which produces the electric field around it. And next one is test charge. Test charge is one which is used to calculate the electric field which is produced by the source charge. That is, test charge is used to calculate the intensity or magnitude of electric field produced by source charge. Test charge is always taken as very minute value, that is, the test charge must be of unit magnitude. And test charge, by convenience, we use as positive charge. That is, a test charge must be a unit positive test charge. The magnitude of test charge must be very small such that it does not influence the electric field produced by the source charge. Next one, intensity of electric field. The electric field intensity is defined as the force experienced by unit positive test charge when it is placed in uniform electric field. The intensity of electric field at a given point can be calculated by using the formula E is equal to 1 by 4 pi epsilon naught Q by R square. Here Q is the source charge which produces the electric field, and R is the distance between the source charge and the test charge. R is the distance between the source charge and test charge. The direction of electric field is determined by the sign of source charge. If the source charge is positive, then the direction is from O to P. The direction of electric field is from O to P. If the source charge is negative sign, that is, negative charge is present as a source charge, then the direction of electric field is from P to O. Next one is electric dipole. Electric dipole is a system in which two equal and opposite charges separated by a distance. Here the distance between the two charges is 2a. Next one is axial line. Axial line is a point which passes through the two charges in an electric dipole. Now let us try to find out the electric field intensity at point P due to a charge at A, and then let us try to find out the electric field intensity at point P due to a charge at B, and finally we calculate their resultant as axial line, intensity of axial line at a point. Use the formula of intensity of electric field E is equal to 1 by 4 pi epsilon naught Q by R square in order to calculate EA and EB. Let us write down 1 by 4 pi epsilon naught Q, the source charge, which is plus Q here, by the distance square. Here the distance is from the source charge to test charge. So AP whole square. That is equal to, here we have taken only the magnitude of source charge, 1 by 4 pi epsilon naught Q divided by AP can be represented as OA plus OP. Hence OA plus OP. Here in the dipole, the distance between the two charges is 2a. Then the distance from A to O is a, small a, and from O to B its value is also small a. Then the equation EA, intensity of electric field, can be written as 1 by 4 pi epsilon naught Q by OA means A plus, here O to P is the distance R, so A plus R whole square. Similarly, we can write 1 by 4 pi epsilon naught Q by, here the electric field due to negative charge at B, which is creating an intensity at P. Then the distance is BP whole square. Here we have taken only magnitude of this charge, that is equal to 1 by 4 pi epsilon naught Q divided by BP can be written as, here BP is not known to us, so BP can be written as OP minus OB, because here OP and OB are known to us. OP as R minus OB as A whole square. Here EA and EB are in opposite direction to each other, because the direction of electric field can be calculated by the sign of source charge. Here EA is the electric field produced by positive charge, which is in a direction from A to P, and EB is the electric field produced by the negative charge, so its direction is from P to B. So here EB and EA are collinear vectors acting in opposite direction, so we can write EB minus EA instead of EA minus EB, because EB is the electric field produced by the charge minus Q, which is influencing the test charge at P. Here BP distance is very less. Here electric field intensity is inversely proportional to square of the distance, that is, lesser the distance, the electric field intensity will be more. So we take EB minus EA here. By substituting their corresponding values, we get 1 by 4 pi epsilon naught Q by R minus A whole square minus 1 by 4 pi epsilon naught Q by R plus A whole square. Here we can write A plus R as R plus A. Here 1 by 4 pi epsilon naught into Q is common factor, so we can write Q by 4 pi epsilon naught into 1 by R minus A whole square minus 1 by R plus A whole square. By taking the common factor q by 4 pi epsilon naught, we can write the above equation as like this. By using simple mathematical formulas, we can easily derive the intensity of electric field at axial line. In the above expression, the numerator is in the form of a plus b whole square minus of a minus b whole square, which is equal to 4ab. So we can write q by 4 pi epsilon naught into 4ab divided by, the denominator is in the form of a minus b into a plus b, which is equal to a square minus b square. So we can write r square minus a square. Here r minus a whole square and r plus a whole square exist, so we can write whole square. The above equation can be written as 2 into 2a into q into r divided by 4 pi epsilon naught into r square minus a square whole square. Here 2a into q is equal to p, which is nothing but the electric dipole moment. So E axial is equal to 2 into p into r divided by 4 pi epsilon naught into r square minus a square whole square. Now we have arrived at the intensity of electric field at the axial line is equal to 2pr divided by 4 pi epsilon naught into r square minus a square whole square. Special case. If r is very greater than a, that is as compared to distance a, the distance from O to P is very much greater, then we can take an approximation as A is approximately equal to 0. Then we can write E axial is equal to 2pr divided by 4 pi epsilon naught into r square whole square, which is equal to 2pr divided by 4 pi epsilon naught into r power 4. By cancelling the r term, we get 2p divided by 4 pi epsilon naught into r cube. Here the intensity along the axial line is inversely proportional to the cube of the distance.